Now we will see the different application for this Lorentz force. The first one is a velocity selector, then mass spectrometer, and then cyclotron. So these are nothing but the various applications. So the first one is your velocity selector. So this is nothing but electron gun is there. So obviously which is going to produce the electric charge, that is mainly electrons, then which is going to pass through this plates, and this is again this is velocity selector. So which you can just select definitely that velocity for which, so by just considering the force acting on that your charge. So if it is electron, so the various forces, one is nothing but the force due to electric field, and again we have just seen that another force which is due to the magnetic field, so which is F is equals to QVB due to the magnetic field and due to this electric field. So either what you can do in this case, so you can just make that charge undeflected or that electron undeflected by just making sure that the value of your force due to electric field is same as that of your due to the magnetic field. So let's say this is EE and this is your EVB. Fine. So definitely this is get cancel, this EE get cancel, and this velocity becomes your E upon B. So where you will get the value of your velocity, so under which there is no deflection for that your electric charge, and again you can just deflect it also for, but for that you can just select the various velocities. So under for this condition, so this is the velocity V, and in that case it will remain undeflected. So that is we are going to call it as a velocity selector. Again this mass spectrometer, the same thing, you have to just project that charge, and again it is going to perform that your circular motion, or it is going to perform that your move along that circular path, yeah, and it is having some that radius for that path, so which you can prove in the next, that is nothing but for example. So now basically what happens, so when it is performing that, so let's say this is the external magnetic field and this is the charge which I project, so assume that it is perpendicular to it. So the force acting is F is equals to Q into V bar cross B bar, and again I can say that it is QVB. So this force is provided, definitely now it is going to move along this circular path, yeah. So now because of which the circular motion is occurring, and for that circular motion, so definitely the all important centripetal force you required. So just compare these two equations where I'm saying that this mv square upon r is equals to qvb, and this vv, one of the v get cancel, and you can say that r is equals to mv upon qb. So by just taking the different charge or by just changing the velocity, it is going to perform that, or it is going to move along the circle of different radius. So the amount of deflection that you can change, or that radius you can change. So that is mainly what we are doing in case of your spectrometer. So where this charge is nothing but moving in both your external electric as well as magnetic field. So the next one, again, that is a cyclotron. So with the help of the cyclotron, again, that is a very important, yeah. So this is the cyclotron where the charge, yeah, so definitely which is nothing but there are two D's, that is nothing but the D1 and D2, and one charge is placed at the center over here, and it is going to perform that your circular motion of constantly increasing radius, yeah. So likewise it is performing that circular motion, and finally it comes out of that window, yeah, and it is going to just hit some target, and where it will just generate a huge amount of energy. So that cyclotron is mainly used to generate a huge amount of energy. This D1 and D2, these are the two hollow Ds, and inside which that charge is moving. So again for this case also, so you can say that you have to set some external frequency for that, yeah. So definitely this is how I can show it, yeah. So this is nothing but these are the two Ds and D1 and D2, the charge is placed at the center, yeah. So likewise it is performing this motion, and finally it will come out. At the same time you have to apply the external supply also over here, and you have to just make sure that the frequency of this your external source just it also matches that your motion of this your charge particle. Yeah, and again it will just alternately it will get change, and the speed is also going to increase according to that. So this magnetic field, so here definitely you have to place in some external magnetic field, and also there is some external electric field is also. For this case, the electric field we are using, it is used to increase the speed, and the magnetic field we are using, it is used to bend it. Yeah, so that's why it is going to gain the speed also, that momentum also. Fine, and again it is performing that, or the radius is also continuously increasing, and then finally it will come out and it will hit the target, which will generate the energy. So we have just discussed the radius, which we can say that R is equals to mv upon qb. At the same time, you can find its frequency also from that time period, that t is equals to, we are saying that obviously 2 pi r upon v. Yeah, so again this is what we can say for this expression, t is equals to 2 pi r upon v. Again, instead of your r, we can just put that mv upon qb, and again this is v. So v get cancelled, and this t you will get, that is 2 pi m upon qb. So this is the value of t, and you can just get the value of your frequency also, which is 1 upon t, which is qb upon 2 pi m. So you can calculate the different things, the time period, then frequency for this cyclotron. So that is about the working for your cyclotron. So that is used to generate a huge amount of energy, where we are using that external electric field as well as external magnetic field.